Okay, so Rainier, I think that's how the name is pronounced, place a beaker of hot water at 100 degrees Celsius on a blue weighing scale as shown below. He then placed a glass lid over the beaker. The glass lid sits firmly on the beaker. Right, so you have a beaker of hot water here. So hot water evaporates faster, we all know that, right? What would be observed on the underside of the glass lid? Okay, so that as the hot water evaporates, it meets the glass lid. Now the glass lid is at room temperature, so there will be some heat loss. Whenever water vapor loses heat to a colder surface, water droplets will form because of condensation. So when warmer water vapor uh, loses heat to a cooler surface, condensation will, alright, and what this means is that water vapor will change state to become water droplets. Right, so we know that warmer water vapor loses heat to a cooler surface. Condensation will occur and water vapor will change state to become water droplets. That's what condensation is all about. So what would be observed on the underside of the glass lid after 3 minutes? What would be observed? Uh, okay, so basically water droplets uh, would would appear. Water vapor, this is wrong. Water vapor would condense on the underside of the glass lid to become water droplets. Okay, so water vapor would condense on the underside of the glass lid to become water droplets. So I'm alright. Okay, next one. Would the reading of the on the weighing scale increase, decrease, or stay the same? Now, just imagine water here evaporating because it's hot, and then it becomes water vapor, but the water vapor still remain on the in within the beaker. It touches the glass lid, it condenses, it becomes water droplet. So when the water droplets gets heavy, it drops back into the water. So the whole entire water that we started with is still within the beaker. So if there's no water escaping, would the reading on the weighing scale increase, decrease, or stays the same? Remember again one more time, the water in the beaker evaporates, touches the colder surface, becomes water droplet again, and drops into the water. So, would the reading on the weighing scale increase? Because there is no water escaping, alright, the water will always be the same. So, if the water will always be the same, therefore the reading will always remain the same. Why? Because the water droplets formed on the glass lid, came from the water in the glass, so there is no overall increase in mass of the water. Right? You can also say that the reading would remain the same because this is quite difficult sentence structure. If you want to simplify it, you just say the reading would remain the same. The water evaporates uh, and becomes the water evaporates inside the Okay, I just said there are no there are no water within the beaker could not escape, right, into atmosphere, right? Therefore, the mass of the water would not change, right? So the reading would remain the same. Why? Because the water within the beaker could not escape into the atmosphere. The water and the water vapor within the beaker could not escape into the atmosphere, right? Could not escape out of. You can also say cannot escape out of the beaker. Cannot escape out. Cannot escape the beaker also can. Therefore, the mass of the water would not change and would always remain the same. Okay, so doesn't mean that in the previous question we saw that the water in the beaker actually became lesser because the water evaporated into the atmosphere. But in this case, the lid prevents it from escaping, and the water keeps dropping back into the beaker. Therefore, there would be no change of water volume, and there would be no mass. So the readings here would remain the same. Thank you.